Hello everyone, in this lecture I'm going to introduce another geovisualization technique, which is animation. Okay, and when we're talking about animation in the context of GIS and geography, um, it's most likely that we're talking about animated maps instead of animated other things, okay? Because animation can be created not only on maps or for maps, right? It can be created for movies, for documentary, for other things. But when we're talking about animation in the context of geography, it is the use of different motion techniques to display data change on a map instead of on a movie screen or on your TV. Okay, or use animation to convey, to address changes for other types of for other types of data. Okay, here when we're talking about animation in GIS, is for the visualization of geographic data sets. Okay, animation is actually a new thing. It began in 1930s, so it's less than 100 years old. And Professor Tobler created the first animated cartography in 1970. I'm not sure if you remember, I mentioned him in the first lecture of this class. He was the person who proposed the first law of geography, right? So here is a YouTube link showing you his work, his animated cartography. And he was actually using a very fundamental but important animation technique called stop frame animation. Okay, and animated cartography was not that popular before the invention of internet, of the web, because back then you didn't have convenient software to create animations, and you didn't have efficient method to distribute your animation. Okay, and stop frame animation, I mentioned this phrase when I mentioned Tobler's first animated cartography, right? It is one of the oldest types of animation in existence. So individual frames are designed one by one, and the steps are as follows. So firstly, you capture an image, okay, and then you make a slight adjustment to the subject, okay, and you capture another image for that subject again, but this time there will be small change to that object in that image, right? And you repeat 2 to 3 until you captured all designed images. And here each image is considered as a frame. So a frame is a terminology used in animation to address a static image. Okay, so you view the images in order and quickly, and you will have the appearance of motion. So here you can see that animation is actually using people's misconception. What misconception? This, for example, if you put an image in front of an individual, and when you make that image disappear, there will be a very short persistence of that image in people's mind, even that image just disappeared. And before that image in people's mind disappears, you just show another image to people again with a small change in that image. And you repeat this process, people will have that misconception that they're looking at something that is moving in front of them. But that is not the fact, right? Because you are simply showing them different static frames very quickly. So people will have that misconception that, okay, something is moving in front of me, and that is actually animation. Okay, so this is very common for animations of temporal data. actually showing or addressing temporal data is, I think, is the biggest advantage of animation, because you can simply order different frames by time and show them and make I mean show them to people quickly to actually to make an animation. For example, the population of a specific area, right, in different decades, okay, and order them by time and show each map of population to people quickly. So people will say an animation of population in different decades for that specific area. Okay, so example, percent population change is not population, is population change, okay, of Virginia, Maryland, and Delaware in different decades, right? The same mapping strategy has been used for different decades. Here is the legend, but you can say for a specific decade, that map will stay there for several seconds and then jump to the next decade and repeat this process. So this is a very simple animation, right? So you just need to make several thematic maps and order them by time and show people this this maps one by one, and they're ordered by time, of course, right? So this is a stop frame animation. And in order to make your animation smoother, you may want to use some technology called twinning. In-betweening or twinning is a process of generating intermediate frames between two images to give the appearance that the first image evolves smoothly into the second image. Okay, so here, let's get back. So you can see that there is huge change between any two frames here, and your eyes can sense that. There is no in between frames to connect two keyframes, right? So there is no twinning technique in this animation. But let's see this YouTube video. 1 second, I'm going to show you. Okay. So you can see here, the author of this animation is drawing another fist here in red. That fist image in red is actually an in-between frame. Okay, I'm going to jump a little bit. So you can say keyframe, there are two keyframes here. One is this fist spreading out like this, right? This blue image here. Another one is this fist holding, right? This fist is not spreading out right now with this blue frame here. So between these two keyframes, the author created multiple in-between frames in red to make sure that when the animation is running, right, it's smoother. See, it's smoother. If you only show two keyframes, it's just a, a holding fist and a spreading a spreading hand. So if there were only 2 frames, this animation cannot be called animation because this change is just too huge and there is nothing between these 2 images, 2 frames. But if you add more, say, frames or images between these 2 keyframes, it's smoother. Okay, so that's actually the definition of in-betweening. Okay, so this is a more advanced technology, say here. This is a more advanced technology, but I think it's necessary to introduce it to let you know. Okay, in general, in our daily research or application of GIS, when we're making animation, in most scenarios, we don't need this technology. We simply make different maps and just order these maps by time and show them one by one quickly, and that's good enough for our animation, which means animation in geography. But you should know that if you want to make it smoother, you can use some technology called twinning or in-betweening. Okay. Okay. Example here. Firstly, we have this keyframe right here, top left of the figure, and at the bottom right of this figure, we have another keyframe. Of course, you can simply use these 2 keyframes to show the animation, but the change will be pretty big from this circle to this irregular polygon. Nothing happens between them. In order to address this issue, of course, you can just create multiple frames between these 2 keyframes to show how this change happened across time by time. But you should know that this in between frames, they do not actually represent the actual change of this feature. Okay, it means that, okay, from this circle to this irregular polygon, there is this change. But this change did not necessarily follow these frames to happen. You just wanted to use this in-between frames to make this change smoother. It doesn't mean that this change happened following these frames. Okay? Okay. And now let's talk about visual variables used in animation. Here, this figure here, I believe you have seen it multiple times, maybe in cartography class, and I also use it before in former lectures. Here we have different visual variables for all types of maps. But in animation, we use special visual variables. Okay, I'm going to introduce them here. First one, duration. How long a particular map frame in an animation is shown before the next frame in the animation is presented. Okay, I think this one is very straightforward, right? And the next one is called rate of change. How quickly an image is morphed into or switches to the next attribute. For example, the ratio of MD between M and D. It addresses magnitude of attribute divided by duration. So rate of change is actually trying to address how much change you want to portray within a specific time in your animation. I will give you an example later, okay? Don't worry. And order of how things are presented. Okay, we don't have to order only by time, perhaps by value instead, but you should know that time is the most commonly used order in animation, especially in geographic animations. Okay, here is an example of rate of change. Okay, so we have 2 comparisons here. In the first comparison, we have an animation with slow rate of change. We have another animation with fast rate of change. You can say there are 1, 2, 3, 4, 5, 6, 7, 8 frames. If your rate of change is slow, you can say this linear feature was not there in the first frame and appeared in the second frame, and it grows gradually in the rest 7 frames with a slow rate of change. So that's the final frame for this animation. You can say that the linear feature is not very long, but if you change the rate of change of this linear feature, you can see here within 8 frames, obviously at the end you have a much longer linear feature because the rate of change is high in the second animation. Okay, so that's the reason why I said that rate of change is trying to address how much change you want to happen within a specific time. Okay, and here is another example showing you the same thing. Okay, rate of change, comparison of rate of change, but it's not for a linear feature, it's for a polygon. And the next variable is called display date. Represents when a place or a variable is first shown within an animation. Okay, so during the animation, some features will disappear. Some new features may appear during the animation. So display date is here to address what the first shown of a feature, of a place, of a variable in your animation. And next one, frequency, the amount and regularity of an attribute occurring within a unit time. Okay, here is an example: nuclear detonation since 1945. You can just click it and watch it yourself. I just want to use it to show the definition of frequency. For example, in a specific year, there are 10 nuclear detonations, right? In another year, there are 100 nuclear detonations. Okay, obviously the frequency of nuclear detonation in the second year is much higher than the first year because there were 100 detonations in the second year and there were only 10 detonations in the first year. Okay. And another variable is called synchronization. 2 or more animated data sets that are related, okay, used for highlighting temporal correlations and relationships, which means that in one animation, you want to address 2 or more data sets or 2 or more features. Examples here. So we have data set 1, we have data set 2. Data set 1 is for the change of a linear feature. Data set 2 is for the change of a polygon feature. Of course, you can use 2 animations to show the change of this linear feature and the polygon feature separately using 2 animations. But you can also use something called synchronized animation or simply synchronization to show both of them in one animation. Obviously, it's more this animation is going to be more complex, and you will have to do more work to make sure that both of them can be addressed clearly in your synchronization. But you should know that you can do this. Okay, it's like a stacking. It's a stacking or overlaying. Okay, overlay or stack 2 animations and make a new animation, okay, containing both features here. Okay, I will just stop here and I will use another video to finish this lecture, starting from tips for designing animations. Okay, I'll stop here for this video. Okay, thank you.